Alright, looking at do now problem number 1, we're asked to solve this equation. We're going to remember that when we are solving equations that we are going to solve them in reverse order of PEMDAS in terms of inverse operations. So I'm dealing with additions and subtractions first. And actually we learned yesterday that really to make this most feasible, we're going to go ahead and change all subtractions to additions anyway. So looking at this one, we have x over negative 2 plus 8 is equal to negative 5. So I need to do the inverse of this addition first. So I'm going to add the opposite of 8 to both sides, x over negative 2 plus 8. And I'm going to add a negative 8 to both sides is equal to negative 5 plus negative 8. So when I add these two things up, I know those add up to 0, so that gives me x over negative 2 plus 0 is equal to negative 13. So moving forward, this step may not be one that you necessarily have to show. If you show me this work up here that you know this adds up to 0, and I would be willing to accept that work moving forward. So x over negative 2 is equal to negative 13. So we know that what we're trying to do here is we're trying to get x alone, so we need a multiplicative identity. Well, the multiplicative inverse of dividing by negative 2 is going to be to multiply by negative 2. And again, we know that that works out that way because this is like giving me negative 2 over negative 2 times x, which is really just 1x, is equal to negative 13 times negative 2. And so that tells me that x is equal to a negative times a negative should give us a positive 26. And as we look down at all of our answer choices are negative 26, which is not the correct answer. So the answer is E, none of the above. Some other reminders and some things that we're going to need today. We need to distribute this expression. In order to do that, the first thing that we need to do is change this subtraction to an addition. So we will make it to add the opposite. And then we want to distribute. So it's going to give me negative 2 times 3a plus negative 2 times negative 4b squared. Negative times a positive, it's going to give me negative 6a. And a negative times a negative, so negative 2 times negative 4 is positive 8 times b squared. And as we look through our answer choices, this is going to be answer choice B. Finally, we want to simplify this expression. So it looks like we need to combine the like terms here. Change this to add the opposite. It tells me I have negative 4x plus 3x. That's going to give me, this is more negative than it is positive, so that's going to give me a negative 1x. And that can be rewritten as just, looks like they've got all the x terms first here. So negative 1x plus 6. That's why we need that addition to do that commutative property. And then we get negative 1x. That's just the same thing as negative x plus 6. So that's answer choice C. All right, let's move on and look at our aim for today. All right, today's aim, we're going to write, simplify, and compare equivalent expressions. And we're going to do this in the context of some real-world problems. So we're going to start here looking at this first problem. It says John's father asked him to compare several different cell phone plans and identify which plan will be the least expensive for the family. Use the information below contained in the table to answer the following questions. So we have this information we're looking all across for company A and then for company B, for company C. If it really helps you, you can call them Sprint. Let's call it T-Mobile and Verizon. If that really helps you, go ahead. Think about it that way. 3 companies. And looking at the chart here, we have a monthly fee. So this means that no matter what we do with this plan from each of these companies, we are going to be paying that amount. In addition, it looks like we'll be paying $20 per line, $15 per line of unlimited texting, and $15 per line of internet access for company A. So we want to write an expression to represent the cost for each of these. It says all members of the family may not want identical plans, so therefore we're going to let X equal the number of people, the total number of phone lines, Y represent the number of phone lines that will need unlimited texting, and Z will represent the number of phone lines with data access. All right, so we need to write an expression for each of these. So I will help you out with the first one. It's going to cost $70 no matter what. So $70 is our starting point for company A, plus $20 per line. So that's $20 times however many lines there are. Additionally, we have $15 for line of unlimited texting, so that's $15 times however many lines we decide need unlimited texting. And finally, $15 for every line with internet access. All right, go ahead and write the expressions for company B and company C all on your own. So the expressions you should have written here are 90 plus 15x plus 10y plus 20. And over here we see that these two things are included in the monthly fee. So those are going to come at no cost. So no matter how much x and y, or y and z are, those are going to come at no cost. So we have $200 up front no matter what, plus $10 for each line, and then looks like everybody gets everything as part of the monthly fee. All right, so now we want to come over, and the next question asks us, well, we're going to use the expressions above or to the left to find the cost of the families for each company's phone plan, given the context. So for each of these, we're going to start with the original expression. So for company A, we have we have 70 plus 20x plus 15y plus 15z. For company B, it's 90 plus 15x plus 10y plus 20z. And for company C, it's 200 plus 10x. Now, as we read through this first scenario that's given to us, we have 4 people that want a phone line. So we know that value is equal to x. X is equal to 4. 4 people want unlimited texting. So we have the unlimited texting, that's y. So we have 4 people. Y is equal to 4. And the family needs 2 lines with internet. So we need 2 lines of internet. So z is equal to 2. So we want to determine which cell phone company should this family use if this is what the family needs. So we're going to have to go in and we're going to have to substitute in for each company. So that's going to look like for company A, this is 70 plus 20 times 4 plus 15 times y is equal to 4 plus 15 times z is equal to 2. And then we're going to have to go through and simplify that expression. So go through company A, B, and C. You're going to have to pause the video to do this and determine which company John's family should use, and then tell me why. So do all of the simplifying to find out the value for each, and then tell me which company he should use and why. Alright, at this point you should have gone through and simplified and found that with Company A, the total cost would be $240 per month. For Company B, it would be $230 per month. And for Company C, it would be $240 per month. So looking at this, we know that John should use Company B because it's cheaper given these values for X, Y, and Z. But the question remains, would this be the same if we had different values of X, Y, and Z? So let's look at a different scenario for John's family. All right, so for this scenario, it says 4 people want a phone line. So X is equal to 4 total phone lines. 4 people want unlimited texting, so Y is equal to 4. And all 4 people want internet lines, so Z is equal to 4. So when we look at this, again, rewriting out our equations for each company, and there are expressions for each company, and then putting in the values for X, Y, and Z, determine which company would be cheapest. Pause the video now to get your work done. Alright, so looking at this, again, we look through this, we do the simplification, we see that Company A is $270 per month, Company B would be $270 per month, but Company C, despite the fact that it costs so much up front, it's so much cheaper per line for all of the extras that it actually comes out to only $240 per month. So they should use Company C because it's cheaper given the X, Y, and Z. Before we move on, I just want to handle a handful of questions about this. So why do we see no equal signs in the expressions? And here you have to consider, like, hopefully in your brain you're going, well, there's no equal signs because we're writing an expression, not an equation. There's nothing that we are looking for this particular company to be equal to. We're actually just simplifying to find out what they would be equal to. So each plan for 4 different options, yet there are 3 variables in the expression. Why is this? Why are there only 3 variables when there are 4 different parts of the expression? Well, when we think about it, the monthly fee is added on regardless of how many lines there are using it. So it's a flat fee no matter what. So there's no variable to go with this because that happens no matter how many phone lines there are. Thinking about like what the minimum cost would be, well, if there were, looking at this, if X, Y, and Z were all 0, that would lead us to our minimum cost. So our minimum cost would be $70 for Company A, $90 for Company B, and $200 for Company C. Because X, Y, and Z were 0, all of those terms would end up being 0. So thinking through this, just when we went through this, what did we do in order to solve this? Well, we wrote the expressions with our variables, and then we plugged the values in for those variables and simplified. And that's kind of an important process. The great thing about writing the expression in this particular case is that we were able to write the expression once and then try out a whole bunch of things. At some point, I will teach you guys how to use Excel in order to calculate these things many times. And once you write an equation or expression, you can use that equation for hundreds and hundreds and hundreds of times, and you can use it and the computer will calculate for you hundreds of different values depending on different calculations that you might want to choose. And it would only take you about 35 seconds to do hundreds of calculations on Excel. And so this is kind of where we're going with this. Alright, let's flip on over to where your partner work is. We're gonna have you self-guide through this a little bit, but after you finish each, I'm gonna want you to stop and answer some questions. We're gonna start over here on exercise, our second exercise in the Together time. 3 friends went to the movies, each purchased a medium-sized popcorn that cost P dollars, so P dollars for the popcorn, and a small soft drink, S dollars for the soda. Write an expression that represents the total amount of money in dollars that the three friends spent in the concession stand. Go ahead and do that now, and then I want to check in with you about what answer you may have chosen. So looking at this particular expression, there are two different ways that we could write this depending on how you thought about this. Many of you may have thought about it as like, well, each person spent P plus S dollars, and if I multiply that value by 3, we could have gotten 3P plus S. Now, if that's not the expression you wrote, is your expression equivalent? Is your expression the same? Well, thinking through this, some of you may have written the expression 3P plus 3S. How would I know, looking at the original expression that I wrote, that your expression was the same or it was equivalent? What could I have done to consider that? Hopefully you're thinking through this and you're thinking through, well, if I use the distributive property, I can distribute the 3 to the P and the S to see that the expressions are indeed equivalent. So it's just the idea of either grouping them by saying P plus S is what each of them spent, or breaking it apart and saying in total we bought 3 popcorns and 3 sodas. Really, they're all the same. So come down here. What information did you use to write the expression? So hopefully you said something along the lines of popcorn cost P dollars, and soda costs S, and all 3 people bought both. If the concession stand charges $6 for 50 cents and for a medium-sized popcorn and $4 for a soft drink, how much did the three friends spend on the refreshments altogether? Please go ahead and pause the video, solve this, and then we'll come back. Alright, so looking at this, I've come up with 3 sample answers, and we can see that they all end up with the same solution. So what's the difference between how these particular students went about it, and are all of their methods acceptable? So when we look at this person started with the already distributed expression, and so they've plugged in, they did their multiplication, and they've moved on. This person kind of went with the non-distributed. They added what was inside the parentheses, got 10.5, multiplied by the 3, got 31.5. The last person went with the non-distributed, but they plugged the values in, then they distributed, did each multiplication, and then moved on. So all answers are okay. It's all just a matter of which way do you want to move forward, which is the best for you. One thing to notice is that had we come through and we used the expression 3P plus S, that expression is not equivalent because that means they would only be buying 1 soda. So that is not an equivalent expression. On our final exercise, we're going to explore the idea of writing equivalent expressions and you creating your own and recognizing how you can use algebra to kind of work through and write different expressions. So for each of these expressions, you're going to write 3 different equivalent expressions. So just some hints on some of these. You can use some factoring to do here, and then you can break it apart maybe on over here. That's kind of what they've done here. They went from this form. This is the distributed form. And then they actually broke apart some of the different pieces inside of it. This one, it looks like they have already got it distributed. So maybe you want to come over here and do the factoring to get this one here. And then maybe break apart some of the distributed form here. This one appears like they've broken some things apart, so maybe you want to put them back together. This will give you the distributed form, and then maybe you want to give the factored form over here. Once you do that, then you'll go ahead and plug in the values to find the individual values. So go ahead and try number 1 on your own. Go ahead and pause the video to do that, and then we'll check in to see if you have similar solutions to mine. So here quickly as an intermediate, you can see that I've gone ahead and I've rewritten the expression. For this one, I distributed. I had to change this to an addition first by making it add the opposite before I could distribute. And then I broke apart this negative 20y into negative 10y plus negative 10y. Part of the reason I might have done that in the real world is if I wanted to multiply by tens, which is a whole lot easier sometimes than some other things. So maybe I wanted to break that apart to get more compatible numbers. All right, go ahead and pause if you haven't already to go ahead and finish simplifying these. And here we've got the final answers. This proves to us that these are indeed equivalent forms because when I simplify them, I get the same value throughout. All right, now go ahead and write the last two. And go ahead and finish those, and then we'll check in with our answer. So go ahead and pause the video until you finish those two. Just as a quick check-in, these are the expressions I came up with. Yours don't have to be exactly the same as mine, but you can see that when I went through here is I took this one and I combined my like terms for this expression, and then I went ahead and factored this expression to give me the non-distributed form. For this one, same thing, this is distributed, so I factored out a positive 3. And then for this one, I took the original and I broke apart the 10y and 2y, because 10y is just a really easy number to multiply with. Alright, go ahead, and if you haven't already, pause the video again and plug and simplify. So looking here, we have our final work here. We should simplify all of these to get negative 39. All of these simplify to get negative 10. And that's how you can kind of prove what you wanted. So kind of thinking about this, like kind of our closing discussion here is you have to consider for yourself, were any of these expressions easier to work with than the others? And as you consider that, many people will say that a lot of times these, which we call the more simplified answers with already distributed, tend to be the easier ones to work with. It's just why we often call them the simplified versions. Does it really matter, though, which expression you use? And obviously, your answer to yourself is no, Mr. Boots. It clearly does not matter which one you use. We get the same answer regardless of what you want. And kind of that's the idea of part of today's lesson, is thinking about being able to identify equivalent forms of expressions that we can kind of use depending on the need, which one may be easiest to work with. So just wrapping things up really quickly, thinking about today, we've talked about how expressions are these kind of number sentences that don't have an equal sign. Sometimes they may have variables in them, sometimes they may not, just kind of depending on whether you know everything in the expression. If we want to evaluate an expression, we need to plug in the values and then use order of operations to simplify it down. And then we can determine if expressions are equivalent by kind of just going through and plugging in some values and seeing if they come out the same. That's one way to kind of check to see if expressions are equivalent. All right, please go ahead and move on to your independent alone time work. It should take you hopefully just a few minutes to write an expression and find an answer. Once you've done that, go ahead and move on and get some con work in.